All right. Hello, ladies and gentlemen. Let us start with this quick review on type of chemical reactions. Just got my pen color. Let's make sure I got my pen. Whoop, yeah, it works. All right. So we're going to have 5 classes of reactions. And these are going to be the basic 5 classes that we're going to expand on. And basically, we're going to go from basically moving different elements to hydrogen and then going to electrons. So from all this, so 5 basic classes. And I do want to point out that as we keep on going through this semester, we're going to start breaking these classes down to more and more specific classes and more specific type of reactions. So this is just what we call general, and then chemistry breaks things and organizes them into different other classes. So what we have is we have 2 synthesis or composition. And when we have this type of reaction, we've got 2 elements that make 1 compound. So we're taking 2 and produce 1. And the simplest one I can think of is hydrogen, and we've got 2 of these, plus O2, and we'll produce H2O. Now, I'm not putting any phases down. We'll get to that in a minute. But this is basically what we call a composition or a synthesis reaction. 2 goes to 1. So A plus B goes to C. Hope everybody can realize that. Now, in decomposition, it's a little bit different. It's the reverse. 1 compound, and we break it apart to get 2. And with this, here's the compound. We've got 2 mercury oxide. And yeah, I know we got 2, but we've got 1 compound. And we end up with 2 mercury atoms plus an oxygen being gas off. So this is, and the cool thing is this is red, this is silver, and we know this is a gas. So we end up with a red solid that converts to something silver, and we get oxygen produced. And this is a liquid. So we got a solid producing a liquid and a gas. Decomposition. Now, single displacement. This is cool because this is where we have a lot of things happen, and a lot of chemistry involved in this. But we have an element. A is an element. B is something in water, in a water or aqueous solution. And so what happens is that when we put A and B, C together, this is a solid, and so it's usually a metal. And what happens is that A replaces B, and B becomes a metal, and AC is the solution. So one of these reactions is basically we have copper plus we have silver nitrate. And what happens when this is going to single displacement, we'll end up with silver solid, elemental silver plus copper nitrate. Now, what is the cool thing about this? And this also happens with acids, but instead of a solid, let's change. I got to balance this out. We'll talk about that in a minute. That's 6. What comes up? We're going to have 2. This is in solution, so this is single displacement. The hydrogen is getting replaced by aluminum, and we end up with hydrogen gas. So instead of having a solid, we end up with elemental hydrogen being released. These 2 are still single displacement reactions. This is more of an acid base in a redox reaction. We'll talk about those later. And this is a redox reaction, but it's what we call single displacement. All right. Now, double displacement. We've got 2 compounds they're in solution, and the cations switch places. So A goes to D, and then C goes where B is. So with this, both of these are in solution. So both are in solution. This is going to be a solid. This is still in solution. So with a double displacement, we're taking 2 solutions, combine them together, and we get a solid produced. Sometimes a gas, but usually it's a solid. And with particular action, and I'm going to rephrase myself, you can also have a liquid produced. And I'm thinking about acid-base reactions. Is a particular type of double displacement, and we'll get into those later. So a classic one that we always talk about, which is real neat looking at, whoops, PB, I can't, NO3, and where this is 2. So remember, anything in parentheses is a unit. So NO3 is 1 unit, and we have 2 of them. So we've got 2 units of NO3 attached to lead, and we've got sodium chloride, and we're going to have 2 of these. And what happens is that we're going to get lead chloride falling out of solution. Sometimes you see an arrow plus 2. I got to make sure I get everything right. 2 NO3. Remember, this breaks apart in solution. They come apart, and the sodium bonds are just 1 NO3. So this is why we need 2. This is what we call double displacement. 2 compounds in solution, and the cation switch places. Next is what we call combustion. It's a specialty reaction, one that we kind of introduce this to everybody because we're all familiar with it. It's something burning. So you're always going to have oxygen gas. This always shows up in these type of reactions. And you're going to get usually a compound that contains carbon and hydrogen, a couple of elements maybe, but definitely carbon and hydrogen. And you're going to get carbon dioxide and water, H2O. And so when we have, this is what combustion. You always reduce in something that's highly oxidized and something that's high, and then this is also hydrogen is highly oxidized. So this is the ultimate redox reaction. We'll get into those later, but this is burning, CO2 at H2O. And we'll learn how to burn these. And this is one that we talked about last year, where sometimes it's based on how many carbons you have. You may have to multiply the whole equation by 2 to balance it correctly. This is the end of the lecture.